Again, and welcome back to Algebra 2 Notes with Miss Faust. Ooh, I'm gonna go close my door real quick so no one comes in. I'll be right back. Hold on, write down the essential question while I'm gone. Okay, I'm back. Whew. Okay, so we are on lesson 1.2.1. 1 just means the unit. 2 is within the book, it's broken into modules, and then 1. So 1.2.1, essential question, how can you identify the features of an absolute value graph? So an absolute value function is something you may or may not have seen before, but by the end of today you will know everything you ever wanted to know about it, and then some. So first we need to take a look at the function. This function looks like this, with the two little bars around the x. So this is the most basic absolute value function. And the absolute value means a couple of things. Well, one thing, but we think of it a couple different ways. So one thing to think about is it's the distance from 0 of a point. So the absolute value of 2 is 2. The absolute value of -2 is also 2. So another way to think about it is just the positive value of whatever your number is. So if we take a look at this, build a little t-chart like we're used to from Algebra 1, and say we put in -3, -2, -1, 0, 1, and 2. So the absolute value of -3, well, if you think about -3 on a number line and you counted how far it was from 0, it would be +3. So f of x is 3. Absolute value of -2 is +2. Absolute value of -1, +1. Absolute value of 0 is just 0. Absolute value of 1, well, that's still 1. And the absolute value of 2 is still 2. So you can see all of those are positive numbers when we look at the function values, even if we start with negative numbers. So what we can do then is we can draw a nice little graph of this. Doesn't need to be too big, but just big enough to get the idea. And I'm actually going to do this. You'll see why in a moment. So the points that we've got there, we've got a -3. So again, oops, x's, y's. So -1, -2, -3, -4, 1, 2, 3, 4, 1, 2, 3, 4, and so on, and -2 down there. So -3, 3, go back 3, up 3. -2, 2, go back 2, up 2. -1, 1, 0, 0, 1, 1, and 2, 2. So what you can start to see is that this is shaped like a V. I can go ahead and connect this, and those would just keep right on going in that direction. And they would keep right on going in that direction. So that's the most basic absolute value function, just the absolute value of x. A couple things to notice about this function. The domain, well, we can take any number, right? This arrow tells us that we're going on forever to the left, so it's -infinity to, oh, another arrow, +infinity. The range, so again, if we take a look at that graph, notice that the smallest y ever gets is 0, and it goes up forever from there. So the range is 0 to +infinity. And again, that's the domain and range just for this basic absolute value function. Once we start moving them around, we'll see that the domain will never change, but the range will change. And I'll just note that here. It may change depending on what other functions we're looking at. So I'm going to take a minute now and I'm just going to show you a whole bunch of other absolute value graphs. So let me just bring these graphs over to where you can see them. You can see I'm using Desmos again. So what I've got here, in a second you'll see that there is a graph in red and there's a graph in blue. The red one will always be that basic absolute value function like I just graphed for you, and the blue one will look at what happens with some transformations. So the first transformation would be a shift to the left or the right. And what we can see then, we can shift the graph to the left, or we can shift the graph to the right. Notice that the basic shape stays the same. And what I have it set so it's just going in integers now. So all of these still have all the same domain and range. When that will change is if we start shifting it up and down. So let me just put it back where we started. If we look at moving the graph up, so if I move it up 3 units, notice now for that blue line that the graph starts at 3. It doesn't start at 0 anymore. So our range would be 3 to infinity. Our domain would still be negative infinity to infinity. And we can move it either way. We could even move it up and down and left and right, and hopefully it'll come back into where we can see it. So just to show you all the different possible examples of that basic absolute value function as we shift it around. So let me bring it back up. That one, for example, is shifted right 1 and shifted down 3. And in a minute, we'll look at how we write the equations for that. Second thing I just want to take a look at is what happens when we start stretching the absolute value function. So again, here we've got the basic function. I put these 2 little points so we can see, actually let me label them even, so we can see where they go when we start stretching it. So if I change it and I stretch it by 3, for example, notice that what was at 1, 1 is now at 1, 3. So instead of going up 1 and over 1 each time for the absolute value function, I go up 3 and over 1 and up 3 and back 1 to get my other points. Still the same shape, just the V is stretchier, closer together. So -3, -4, past that we can't see a whole lot, but the negative flips it and stretches it. I like to think of that A, or the stretch, as being like the slope, because it goes over 1 and down 4. Okay, and then the last thing to look at is we can put all of those things together. So we can take and we can do a stretch, say, of 4, and we can do a shift to the left of 3, and we can do a shift down 2. So this function then is the absolute value function. We know that because the basic shape is the same. But it moved left 3, it moved down 2, and instead of going up 1 and over 1 to get to the next one, now we go up 4 and over 1. So that's how the stretches and shifts work together in our absolute value functions. So just to come back over to our notes, you don't need to write all of those down. We're just going to go through and take a couple of notes about that. So let me just move this down. So what we get when we start transforming absolute value functions when we start doing transformations, what we're going to have is instead of f of x just being equal to the absolute value of x, now we're going to have a couple different parts. We can have an a in front, and a could be an integer, it could be positive or negative, it could also be a fraction. We're going to have the x, and notice that x is inside the absolute value part and inside the parentheses. The reason I put it inside the parentheses too is because we also could have a horizontal shift. That's going to be our h. And then at the end, I'm going to put a plus k. So those 3 things together are going to move our graph. So the k is the vertical shift. And remember from before, if it's plus k, it goes up, and if it's minus k, it goes down. The h is our horizontal shift. And again, remember, if it is plus h, it goes to the left. And if it's minus h, it goes to the right. And then a is our vertical stretch. So a tells us how much we're stretching the function. Instead of up 1 and over 2, it tells us like up 2 and over 1 or something like that. So I think of that like the slope in this problem. It's not exactly the slope, but it's similar to how we're used to thinking about slope. Okay, so let's look at how that works when we actually try to graph a couple of these. So I'm just going to turn the page. I'm going to make sure that we are in focus. Oh, I didn't mean to do that. I'm going to focus it, not take a snapshot of it. And now that we're in focus, let me just put this part in and this part in. Again, remember, if you have questions as you're watching these videos, please make note of them in this margin. That way when you come to class and you're like, I didn't understand this part of the video, I can say, which part of the video? And you'll go, this part. And I'll say, oh, that part. Okay. So again, we're going to look at graphing a couple of these. So the first one, whoops, example 1. I know somebody specifically asked that I number examples, so I'm working on it. We want to graph f of x equals the absolute value of x minus 1 plus 3. And I like to put the parentheses and the absolute value symbol just because it helps me keep track of everything. If you don't want to do both, you certainly don't have to. And anytime we're graphing these, we can start with that basic absolute value function that I showed you on the other page. So it goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on. And then negative 1, 1, negative 2, 2, negative 3, 3, and so on. So those are the points that we're going to think about moving as we transform the absolute value function. So first thing to notice here is this negative 1. That negative 1 means we're going to have a horizontal shift. And the horizontal shift, because it's minus 1, is going to be right 1 unit. And then that plus 3, so the plus 3 tells us we're going to have a vertical shift. And our vertical shift is going to be up 1. So we take all of our original points and we think about moving each one of them to the right one. I'm sorry, right 1 and up 3. This isn't up 1, that's up 3. So right 1 and up 3, I'm just looking for another color so that maybe you can see this. So we take each point, start with 0, 0, move it right 1, up 1, 2, 3. Then if you want to do that for other points, you can, or you can just think about the fact that there's no stretch in this one. So we went up 1 over 1 here. So from that vertex, that's how I think of this point, we're going to go up 1 over 1. And that gives us the graph of our new function. Okay, so the new function is this one here. And the way that I think about it is that vertex, or the center point, moved to 1, 3, because it moved right 1 and up 3. So it was at 0, 0, and it moved to 1, 3. And then our other points are up 1 and over 1 from there. Okay, so example 2. We're going to graph again. This time we are going to graph f of x equals 2 times the absolute value of x minus 1 plus 3. Well, that one's going to have the same shifts we did before, right 1, up 3. The difference now is this 2 in front. So when we go to graph that one, draw my grid in again. So my vertex, I move right 1, again from this minus 1, I move up 3, and then I have my A of 2. So I think of that like my slope of 2. So my original function, let me get it in there real quick, 0, 0, and that. My new vertex, or this center point that the graph is starting from, is at 1, 3 again, because it goes over 1 and up 3. So that's that center point where the graph comes from. And then from there, I'm going to go up 2 and over 1 in each direction. So I'm going to go up 2 and over 1, and up 2 and over 1. that gives me 3 points. I can do the same thing again, up 2 and over 1, up 2 and over 1. And that gives me enough of the graph that I can see what that function looks like. Okay, so again, the pink one's the new one in example 2, just to compare to the one we had before. I'm going to do one more example with you for right now, and then we're going to do one more thing in this set of notes. So example 3, we're going to graph, what are we going to graph? We're going to graph f of x equals negative 3 over 2 times the absolute value of x plus 2 plus 4. Okay, so I'm looking at a negative a positive h, so that's my horizontal shift, and a positive 4. So if I think about this, this one's going to be moved up and left, because this is up, this is left, and then it's going to open down. So let's just see here, let's get a little grid built, and I hope I gave myself enough space here to do this. I'm going to do my best. So again, when I look at this, the plus 2 tells me to go left 2. The plus 4, the plus 4 tells me to go up 4. So what that tells me is that my vertex in this one is going to be at negative 2. If I go left 2 from 0, 0, I'm at negative 2 and positive 4. And then my a is negative 3 over 2. So from that vertex, so from negative 2, 4, to get my other points, I'll go down 3 and over 2. So let's look at what that looks like. Point, point, original function, the absolute value function. Now I need the new one. So for the new one, I'm going to go to negative 2, 4, and I'm going to put a point. And then from that negative 2, 4, I'm going to go down 3 and over 2 in both directions. Down 3 over 2, down 3 over 2. And then from those points again, down 3 and over 2, down 3 and over 2. And you can see what our absolute value function looks like. So again, we went to the vertex at negative 2, 4. We knew that because this was shifted left 2 and up 4, which puts us here. Down 3 and over 2 from there because that was our stretch. So down 3 over 2 in both directions. What we're going to look at next is we're going to look at what happens if we start with a graph and we want to write the function. So this was function to graph. Now we're going to do graph to function. I'm going to pause and draw a couple graphs. You'll probably want to draw those in too, so you have the graph and you can just focus on what we're doing with them when we go to write the function. Okay, so last two examples. If you want to pause for a moment and draw these graphs, let me just show you where the points are so you have the graphs ready to go. This first one has a point at 0, 3, right here. And then another point at 1 and 1, 2, 3, 4, 5, 6. And finally a point at 2, 3. So that should be enough that you can draw in that graph. And then over here in example 5, 2, 3, and down 1. So that point's at negative 3, negative 1. This one's at negative 4 and positive 1. And this one's at negative 2 and positive 1. Okay, so if you want to take a minute, pause, and draw those graphs in, and then what we're going to do is we're going to work together at figuring out what the function would be. So remember, the basic form for the function is always f of x equals something times the absolute value of x plus or minus something at the end. So what we're trying to do is figure out what goes in each of those blanks. So if we look at example 4, remember the original absolute value function would have started here at 0, 0. So we can see what this number and this number would be by looking for where sort of the point of the absolute value function is now. And you can see the point of it, or the vertex, is now up here at 1, 6. So from 0, 0, it's moved to the right 1, and it's moved up 6. So it went right 1, and then it went up 6. So since it went right 1 means we're going to have a minus in here. Goes on the inside of the parentheses, a right or left shift. And then up 6 goes on the outside, so that plus 6 goes there at the end. So those vertex points show up right here. So again, those came from this top point of the function. That tells us the 1 minus 1 because it was right, and then plus 6 at the end. So then we need to figure out what the a would be. So remember that a is telling us what the slope is. So if I look at this from this 1, 6 to get to the other points, I see I go down 1, 2, 3 and over 1. So my slope seems to be -3 and over 1. And I can look here again, down 3 over 1. So what that means is the a value, or the number out front, must be a -3. So -3, absolute value of x minus 1 plus 6. And the reason we know it's the absolute value is because it's that V shape. This time it's upside down, but it's still the same V shape, basically two linear functions put together. Okay, and then for example 5, if we look at that one, again, we can think about the horizontal and vertical shift first. Remember, the original absolute value function would be here at 0, 0. Well, this one's moved left 3 and down 1. So our vertex now is at -3, -1. And it moved left 3 and down 1. So left 3 in our function goes inside the parentheses with the x as a plus 3. Left 3 makes it a plus 3. And then down 1 makes it a minus 1 on the outside. And again, that comes from looking at that vertex and figuring out where that is. Again, then we need to think about the a. So we think about the slope. So to get from this point to this point, I go up 2 and over 1, and up 2 and over 1, and up 2 over 1, up 2 over 1. You can see that keeps happening over and over again, but that's just 2. So in front of the whole thing, we put a 2, and our function is 2, absolute value of x plus 3 minus 1. We can talk about the domain and range of these again. I'm going to do that real quick just to keep bringing that back in. I'm going to use D for domain and R for range. So the domain never changes, always -infinity to infinity. Put that in for both of them. As we move an absolute value function, we can still put any number in and find the absolute value and evaluate the function. Range, if I look at the graph of this one's going down forever, so my range is going to start at -infinity. And if I look, it stops right there at 6. So my range goes up to and includes 6, but doesn't go past it, excuse me. And my range for my other one, if I come from the bottom, starts right there at -1, less than or equal to y, less than, arrows at the top, positive infinity. And as I was saying all that, I realized I made a mistake on the very first page in my notes about the range. The range of the absolute value function actually does include 0 because the absolute value of 0 is 0. Since it actually includes it, we want that to be a less than or equal to y. So 0 is less than or equal to y, less than infinity. Please excuse my mistake, and have a wonderful day, Mustangs. Thank you for your attention. Woo!